Hello everyone, I'm Peter Wolf. I'm a cloud operability and integration architect from Nokia, whatever that long title means.
Hello, my name is Gyula Berke, and I'm a software delivery manager at Nokia.
So you can see a slight resemblance to Nokia in the style of the slides. And what I'm going to talk today is how we satisfy ETSI requirements using OpenStack and mostly Heat. So I'm going to assume that you know what OpenStack is, and you probably heard about Heat. You might not know so much about ETSI, so this is a rundown for beginners. The key element here is the VNF. This is the the application which actually does the useful service, and everything else around it is just there to make sure that this service is provided. I'm not gonna read the stuff I put in the boxes, but you can get a quick idea what's what. Basically, the bottom row would be OpenStack, or your OpenStack cloud altogether. Okay, so how do we get here? I mean, Gyula and I. So this is the place for advertisement. So we are working on a product called Cloud and Application Manager, which was mentioned in the keynote speak by Nokia, and this part might be a little bit redundant or at least familiar for you. And this Cloud and Application Manager would be the VNFM from this slide, so the in the middle on the right side. We do the lifecycle management of VNFs, and this is how we got into OpenStack and actually the earlier iteration of this application, but this is why we are into OpenStack and why we have to comply with ETSI standardization. We also deploy it to other VIMs like VMware or in the near future Kubernetes, but obviously today we are focusing on OpenStack. Okay, so the development of a product is defined by 3 words. One is what is possible with Heat and all the capabilities of OpenStack. The second one is all the cases that are handled by the ETSI standard, mainly SOL and IFA group documents. And the third one, probably most importantly, is the requirements of the VNFs, which ultimately represents the requirements of our telco customers. As you can see, there are common points. That's the easy part, and there are things that don't really match up or not at first glance. And for those, we find ourselves sometimes in tricky situations. So how do we cope? So one thing we can do is create vendor-specific extensions. I highlighted 4 areas. One is that we introduced something called heat mapping in the VNFD. I will get back to this a little bit later. Second one is we defined, let's say, de facto interfaces for VNF integrators. These are the guys who are creating the artifacts for the telco application to be used with our CBAM product. And for these, we defined these 2 data flows or data packages. One is the resource model, and the other one is stack params. I will go into these a little bit detail in a slide or 2. So this is to create the bridge between OpenStack and CBAM, or Heat and CBAM. The third one is to extend the capabilities of the standard to allow for the integrators to create operations that are not standardized yet. And the fourth one is just a pointer to show that all of this is not just about resource management, but also configuring. And for this, we use Ansible, and for the integrators to be able to use Ansible playbooks that they create, CBAM generates for them an Ansible inventory, and that's also something that is very well documented, how this inventory will look like and what is included in it. once again, I invite you to remember back the keynote speak about the open templating system, that this is what is contained in all the documentation for these. The other way we cope with these differences is just simply saying no, because some things are not possible to do for now, or other things are simply against the standard. And I guess this is the point of having a standard, is to be limited by it, so you can be sure that everyone else plays by the rules. But I want to highlight again that this is those things that you cannot do are mainly temporary, and because the whole ecosystem is actively evolving, these gaps are constantly closed up, and also sometimes not just saying no, but also telling customers, which could be internal customers, so like a VNF integrator, telling them what to do instead of what they want, or what to suggest to the end customer, the telco business owners. Okay, so what we are going into in this presentation is the heat mapping part, the stack parameters, and how we do scaling, how we approach VNF healing, and how our framework and recommendation goes for VNF upgrade, other than VNF package change. And at this point, I would like to explain what VNF package is. So basically, this is the artifact. This is a Caesar file, which is a fancy name for zip, which has a specific Tosca metadata folder in it, which has a special file which points to a main Tosca. But the whole point is that the whole zip, this whole Caesar file, contains all the artifacts that describe the VNF in the ETSI model, in the ETSI language, and also it contains all the installation scripts and hot templates and Ansible playbooks that is used by CBAM. So when you do an upgrade, it is expected that you change this package, because your scripts and everything else should be new, or at least somewhat changed. Okay, so the first part is heat mapping. So this is the end of the Tosca VNFD. The first part of the Tosca is, as I said, the description of the topology of the VNFD, of the VNF, the telco application, in ETSI terms. And the heat mapping, this is a Nokia-specific extension. What we do is we add two more critical pieces of information. One is the listing of hot templates that are used for deploying the VNF. And the other one is a mapping between the ETSI entities and the actual resources in the hot templates. We also support environment files where you can use resource registries. For the heat mapping, there are two parts, static and aspects. You can only see in the example the static part. The differentiator between the two is that static is something that expected to be there throughout the whole lifetime of the VNF, and the aspects is something that is used mainly for scaling. So this is something that's multiplied during scaling, or reduced during scaling in. And something that is not yet supported is optional resources. These will be things that you can describe or declare here as temporary present, but it's okay if it's not there. So one good thing about this is that from CBAM side, we only care about a few types of resources, like servers, volumes, and basic networking elements. And this allows the flexibility for the integrators to use other resources, and we just simply don't care. CBAM will not break on these. So here I defined a resource that does not exist, as far as I know. And as long as Heat is fine with it, we're fine with it as well. Okay, this is an example of the resource model. So this is, you cannot read this, and you should not, because it's really, really, really big. So this is basically all the resources and all the information Heat has about those resources that are in one single stack. With telco-sized VNFs, these can be so big that if with default configuration, if you ask for this information from heat in a single request, then the single response will not arrive because heat will fail with a 504 gateway timeout error. So to work around that, we have to query these in some smart bulk and semi-bulk and nested depth research algorithms to collect this information. But this is basically the output, the main output of the heat stack, and this will be the main input for CBOM to get information of the current state of the cloud and the resources. Okay, and this is for communicating the other way around. This is the input that is generated by CBOM to be used by the hot template created by the VNF integrator. And this contains two kinds of informations. One is everything that is relevant and written in the VNFD, so the ETSI model. And the other part is the runtime information coming from the instantiation request. What's the difference between the two? VNFD should be environment agnostic. This is the template package you can take with you and go to another cloud and use the same template package. But the instantiation request is very much environment dependent, so this is where you provide the exact image IDs that are present on that cloud instance or the IP addresses that should be used by the VNF in that exact environment. So this is generated by CBOM. This is a really big JSON object, and this will be an input parameter for heat. The parameter name needs to be CBAM. We chose this string because it's very unique and probably no one else uses this for anything else. And this is how you can get information out of it. So the highlighted part is using the flavor information for creating a server. And in this train of parameters, you can see that it starts with CBOM. This is the parameter name. And the content will be generated by CBOM. The simple aspect group represents a scaling aspect. This is an ETSI term. This is coming from the VNFD. The desperate server is a VDUnium. This is the name of a VM in ETSI terms. This is also coming from VNFD. But the actual value for the flavor ID will come from the instantiation request. So this is how all the things connect together, and this is how, in that actual environment, the hot template will be able to get the information to deploying the stack. Here's an example for scaling. So same approach. One thing is though that count is coming from CBOM. I mean at the end of the parameter train. Count is coming from CBOM. So this is the connection between the API of CBOM, the ETSI-defined scaling level, translated to the number of resource groups to be present. So basically, this is how you scale. Is if you want to increase the scaling level, at hot point of view, that's another instance of a resource group. And everything that should scale should be in that resource group. That approach is used or abused for healing. Healing is something that is defined by ETSI as an API operation, but implementation can vary from VNF to VNF, so we don't provide, CBOM does not provide a built-in healing operation. For scaling and instantiation and termination, we do. But for healing, we provide a framework where the VNF integrator can elect to design their own healing approach, which can include simply running an Ansible playbook which reconfigures a VM or issue Nova server reboot or rebuild. Or it can do this tricky thing that I'm going to explain. For all of this, we use Mistra, which is another OpenStack project, which is a workflow engine, and this is how you can write down your custom workflow, which will take care of this healing operation. So what we do here is basically we wrap the VM in a resource group, which by default has a count of 1. And when you set it to 0, you simply remove everything that was inside the resource group. And when you set it back to 1, then everything is recreated, so you start from scratch. in that part of the stack. And this is to work around issues we had earlier when you have a VM with root volume. Then if you change the image that the volume was based on, sometimes heat does not handle that well. For example, it can leak volumes. And also sometimes because of its asynchronity, sometimes Neutron will say the port is still in use by the old VM, even though the VM doesn't exist anymore. So this custom workflow would constitute of the following steps: a calculation of the stack parameters. This is the CBOM JSON file in which the count will be set to 0. Then a stack update is issued, and when the stack update is finished, that means we can be sure that the VM and everything else is deleted. Then we recalculate the stack parameters again, set the count to 1, and update the stack again. We could use conditions for this from Newton on. I will get back to that, why we don't use that in 3 slides. Okay, for VNF upgrading, that can differ vastly between VNFs. Here even the API is not standardized. So same approach, and we need this because in Telco it's not acceptable in many cases to shut down all of your VMs just because you're upgrading them. So you need to have live service. And once again, only VNF integrators can know what is the correct and acceptable order to upgrade your VM. So this is the same approach. You delete the VM that you want to upgrade, change its image, for example, if the image is changing, or a flavor if something else is changing about the VM, and then recreate the whole wrapper resource group. Again, conditions could be used. I'll tell you why we don't recommend it yet in a bit. And once again, this whole thing is declared or defined in a Mistral workflow. So this is basically, from OpenStack point of view, where CBOM is at. We have other features, but those not strongly connected to OpenStack. What we expect from the foreseeable future is that the ETSI Sol group is working on standardizing the software upgrade or update. That would be a step forward, major step forward. Other thing is, we would like to use conditions, but Telco is typically something that requires long-term support. That means, so for now, I think we can drop kilo support. So, but still we have to support all OpenStack clouds from Liberty, actually up until Pike. So that's a vast spectrum, a big spectrum of OpenStack versions. And conditions were only introduced in Newton. So this is why currently we use and suggest wrapper resource groups. The third part is, this is something that I'm exploring right now, is the resource registry of heat, which are used in environment files, which has some fancy and tricky features which could be used or abused for facading resources. So for example, you can probably, I have not tested this yet, but probably can use this to move around resources between stacks, which would be a major feature. So you could lie to one stack, the resource is still there, while it has been moved to another stack, which was previously lied to that, to believe that he always had that resource. And when we delete the old stack, it would not delete the old resource. So, or this could be used, this facading capability could be used to put, to support other SDN providers like the Neutron port with actually hiding the specific implementation and making it look like a Neutron port. And the last upcoming feature for CBOM I want to mention is resource monitoring, and for that we are exploring the usage of heat action check. And another OpenStack project which is backed by Nokia heavily is Vitrage, which is mainly a root cause analysis tool, but also it has some nice fault management and fault analysis capabilities. So all of this was in theory, and now let's see a demo how this works in practice. Oh, sorry.
So let me demonstrate how does it work in practice with our product CBOM Cloud-Bound Application Manager. We logged in the UI of the CBOM, and we will create a VNF. And the VNF name will be OSD Maria, because it's describing a MariaDB cluster. This will be our demo VNF. And we will start an instantiation operation with this VNF. Here we provide all the necessary information for this instantiation operation, like accessing the Vim or provide the Vim password separately. And after that, the instantiation will start. And here we can see the stack list and the instance list by OpenStack clients. And you will see a stack soon in the stack list. Yes, that one. And the name of the heat stack prefixed with a unique VNF ID, which can be checked in the UI of CBOM as well. And you will see 5 nodes here, 3 backend nodes, which are started from root volume, and 2 service nodes, which are started from image. And you can see all the service nodes are active, and you can see the image in the big screen. It's Ubuntu 16.04 IPv6. And now the backend nodes are created. And this is a stack creation. And these operations in real life even more slow. we have heavily cutted this video to focus on the exciting part. So while the configuration part of the VNF is happening, let me show the VNF package. And in it the VNFD Tosca, and in it you will see the heat mapping, and that will be highlighted as well. There is it. And this refers to the main hot template. And this main hot template contains all the heat resources, like nested heat stacks. And we will open one of these nested heat stacks. And we will see how does it look like in resource point of view. Here are all the resources. And the instantiation operation will be finished soon. Yes, and we can start the scale-out operation. This scale-out operation will be a service aspect level scale-out. Ergo, the service node resource group will be scaled out. That means 2 more service nodes will be created via stack update. So the scale operation is running, and we will see 2 more service nodes. And here you can see the relevant resource group is for a service node, and it refers to another hot template, and we will open those other hot templates soon. Here I describe the node A and the node B instances. Refers to another hot template, but this final hot template contains the Nova server. It will be visible soon. But before that, we are filtering for service nodes in the big window. And during the querying, yeah, this is the Nova server here. And after this, we can start a custom operation, a VNF upgrade, where we change only the images. But in this sample, all the nodes are based on this image, so all the 5 nodes will be updated. At first, the service nodes will be rebuilt, because in service node cases, it's a rebuild because they were started from image. And here the first one has the new image already. And soon the second rebuild will be started soon. I think here I move forward a little.
It's important to see that this happens one by one, because
yes, and each of them are separate stack updates. And finally, the last one. Yes. And in case of backend nodes, it's actually a instance deletion and an instance recreation from the new root volume, because they were started from root volume. So let's filter for the backend nodes. And the deletion and the recreation will be separate stack updates. And during the deletion, the instance and its root volume will be deleted also. And the first backend node is deleted. And it will be recreated soon. Here is it. And after the first backend node is in active state, I will go forward a little. Yes. Deleting. Recreating, and the last one will be deleted soon, yes?
This whole thing took 40 minutes, actually, if it was not cut.
And let's go to the OpenStack dashboard, and we will select a backend node. It's the service nodes. Here is a backend node. And the last backend node is recreated. So this backend node was started from a root volume, which is on the bottom. And by clicking on that root volume, we can see that was created on 3:57 p.m. And if you go back to the instance, it is started a minute after that. And the configuration will be done soon, and then the upgrade operation will be finished soon. And for closure, there will be a termination and the VNF delete. The termination will trigger a stack deletion. That means all the VMs will be deleted. This is the termination. And here is the deletion, stack deletion, and all the VMs are deleting. And as you probably know, this video was heavily cut because the configuration and the cloud operation take much longer. Sorry. And when the termination operation is over, we can delete the VNF from the CBAM, and we can log out. Thank you for your attention. And if you have any question, we have 3 minutes.
Is there any question? Yes?
So you have said that in the Tosca template you have Nokia-specific extensions. Are these only hints for the VNF orchestrator, or does it mean additional information for your Nokia OpenStack cloud? So basically I'm asking whether you will need a Nokia cloud to deploy a Nokia VNF application.
No,
this is need the VNF orchestrator to be of Nokia.
Neither. Only the VNF manager needs those extensions. So the CBAM product. So for the orchestrator, this is extra information. They can ignore it, just like we do with the extra information in the hot template. But yes, it's critical for VNF manager. We need to know the mapping between the ETSI entities and the OpenStack or heat resource entities. So we need this, but the other part, the other end, the heat is upstream heat. So nothing Nokia cloud specific in it.
So basically you only need a Nokia VNF manager in addition to the application, right?
Yes.
Thank you.
Any other question? We have 2 minutes to spare. or to spare you.
Okay, thank you.
I don't think any more
Thank you
questions.
very much.
You can come back.
Yes.
So thank you very much, guys. If there is no question, then again, thank you very much for Nokia to sponsoring the event and you guys coming here and actually showing a very impressive demo.